All right, as many of our activities here are designed to, again, get the kids to apply knowledge. In this case, we are trying to give them a story. Now, stories are really effective, even if they're relatively simple, at helping get the kids engaged in a particular activity. So in this case, we're going to create a simple sloped line. We're going to put a weighted object on it. We're going to slide it down, and we're going to measure the amount of friction each of these different strings has. And that's all well and good, but it's really boring for the kids if that's where you start thinking about it. So what I tell my kids is that there's a story involved. They are spies. They're up in the bad guy's mountain. Of course, the bad guy has some volcano or something he's always held up in. So they've got the information, and now they need to escape. So they need to go down a zip line to be able to escape. So in this case, this is the world's fastest zip line. And there it goes. This zip line runs up to 120 kilometers per hour. It's in near Saudi Arabia. So this would be the awesome thing they have in their head in terms of where they're going.
It's a dream come true. Obviously, we stood here months back talking about building the longest line in the world, and here it is. It's a suspended platform.
Not everything can be quite that good in the classroom. It's much harder to do that in the classroom, but give them a story to work with. Especially younger kids, if you're teaching younger kids for any reason, they can work with this. So what I've done is basically attached 4 different kinds of strings to meter sticks. And then I've given all the kids a sample of the string. In this case, this is just a white twine. So they can touch all of them and then make a comparison. So we have a kind of a brown heavy twine. We've got a nylon, a smoother kind of braided line. We've got a single-stranded line here, and then we have some fishy line. And we'll use this to be able to see better. What happens is we stand this up on the table. Just kind of pull it taut. You don't have to go back too far. This would go, here I'm limiting it to the size of the table. On the floor, what I would do is go all the way out across it, so it's got a much longer distance. And then I just take a Dixie cup, and I poked a couple holes in it, and I took a paper clip, and I unbent the paper clip into make kind of a triangle. I'm going to attach that to our twine here. And then hold it taut. The meter stick gives us a nice consistency because they're all start the same height. The length of the strings are all the same, so they're going to have the same slope as they go down. And then we have the kids make an estimate which one of these is going to do a better job. Now, it's not going to take the kids too long to figure out, the fishing line is going to do the better job. So don't leave it with that. Give them a better question to say, hey, you need to go down this thing. You want to go fast enough that you can get away from the bad guys, but if you go too fast, you're going to crash the bottom and die. So you need something that's more of the middle of the road. So it makes them think about this process a little more. And then you let this go, and then the kids use a stopwatch to time how far it goes down there. Now, some of the twine, for instance, sometimes the couple actually literally just stop because there's so much friction between this particular string and the cup. And you can talk about that. So is that bad data? Is that outlier data? How do you use that information? And if you don't have your kids look at the data, you're missing a big part of this process. So have the kids collect data on just a simple worksheet, for instance, and then go back later and then throw that up on an Excel document and then graph it or put it into a chart and say, okay, so are any of these numbers out of order? So if all of these go down, you do it, let's say you do it 5 times each, you roll it down 5 times, and then the numbers are 5, 6, 3, 27, and 8. Well, that 27 number should leap out to your kids like, that one is clearly wrong. And then you have to make a decision. Do you have to redo the experiment, or do you throw out that data knowing that that is clearly an outlier and that is corrupting the average you're trying to collect? You have less information, so now you only have 4 trials instead of 5, but the information is probably much more accurate. So don't let them get away with just writing down the numbers and oh yeah, this one won. That's too easy. Make sure that they go through and actually analyze the numbers. Are they reasonable? Do they show consistency? If they don't show any consistency, something's going on wrong. If they're getting of widely discrepant numbers, then the experiment needs to be improved. Another way to approach this would be to say, okay, so let's find out which one of these is the right choice. In this case, it might be the braided nylon, so it's a little bit smoother. It's going to give a consistent, fast enough to get away, not so fast that you die in the end, which is always good to avoid. But then you can ask them, okay, so how do we make this faster, or how do we make it slower? And so they might have to then come up with, oh, okay, we need to adjust the slope. We need a more a higher slope to be able to speed it up. Or we need to bring this down. We need to slow it down by using a lower slope. Maybe I need to change the amount of mass. I have a washer in here. Maybe I need to use a smaller washer. Maybe I need to add more washer to it, or I need to change the cup in some way so that either adds or reduces the amount of friction on the road. Don't stop with just a simple experiment if you can. If you have time, make it go farther. Extend it with more questions and get the kids to then say, oh, this was a quick experiment about friction, so now we compare the different ropes, we can see how more friction slows down the object, because friction is always opposed to motion. Now let's go back and let's see if we can use that knowledge and then get this to go exactly the way we want it to go. Maybe it needs to go exactly in 10 seconds or 5 seconds or whatever it is that you give them, so that they have to then be much more creative and thoughtful in terms of thinking about how they're going to be able to do that. Thank you.